Okay, with this video we begin looking at the homework problems, and in the first four that we have to do, all we need to do is take a point and a slope and write an equation in point-slope form. So let's take a look at what we have then. Remember that our point-slope form, I'll just write it one time at the top here, y minus y1 equals m times x minus x1. So in each case, I'll label the point x1, y1, and so we have y minus y1 is 1 equals m, which is given as 2, times the quantity x minus x1, which is 2. And that's all we have to do. Done. All we're expected in these four examples is to simply put the point and slope into an equation of point-slope form. Next, now it gets complicated when we have positives and negatives together. So the next example, y minus the y1 is negative 4 equals m, given to us as negative 6, times the quantity x minus x1 is 7. Y minus negative 4 is y plus 4 equal to negative 6 times x minus 7, and that is all we need to do to write an equation in point-slope form. Next example, y minus y1 is 0. So again, I didn't label these, but you can go ahead and do that. x1, y1, x1, y1, x1, y1. And y minus 0 is equal to negative 3 times x minus x1, which is 9. Now the only thing I'd simplify here is that y minus 0 is simply y equal to negative 3 times x minus 9. And we're done with the third example here. The final one, y minus y1 is 6 is equal to the slope 3/2 times x minus x1, which is negative 6. And the only thing I need to simplify here is y minus 6 equals 3/2 times x plus 6. And we have the fourth example here. So we'll pause here and go on to the next group of problems. Okay, then in the next set of problems we want to do something similar, but here we're not given the slope. So we're given graphs, and we want to calculate the slopes, and you can calculate the slopes simply using the graph, and then to put them into point-slope form, and finally the equation needs to be written in slope-intercept form. So let's take a look at the first. From our given point on the left, we go up 1, 2, 3, 4. So it's up 4, and then right 2, which gives us a slope of m is equal to 4 over 2 positive, which is 2. Now we're going to take that, and one of the points, we'll use the one on the left, 1 and negative 3, to write y minus the y coordinate of negative 3 is equal to the slope 2 times x minus 1. So first I'm going to simplify y plus 3 is equal to 2 times x minus 1. Then I'm going to distribute 2x minus 2, y plus 3, and I get, well, first I'll subtract 3 on both sides, and I end up with y is equal to 2x minus 5. And so that is my slope-intercept form. Above that, I have my point-slope form, and above that still, I have my slope calculation. Alright, so we go from slope to point slope to slope intercept. And we'll look at example number 12 now. So again, from the point on the left, we are traveling down 1, 2, 3, 4, 5, down 5, over 1, 2, 3, 4, 5. So that would be a slope of m is equal to 5 over 5. Sorry, it's negative 5 because we went down 5. Very important. When you move down and then to the right, your slope should be negative. And that negative 5 over 5 translates to a slope of negative 1. So we're going to take one of the points. We'll use the one on the left. X is negative 4, y is 0. So y minus 0 is equal to negative 1 times x minus negative 4. And it doesn't matter which of the 2 points we use. The intermediate point-slope form may be different, but the eventual or ultimate slope-intercept form should be the same. So y minus 0, I can simplify that down to y equals negative 1 times x plus 4. When I distribute the negative 1, I get y is equal to negative x minus 4, and that is my slope-intercept form that goes with the point-slope form that goes with my slope calculation. Now, you can tell by looking at the slope-intercept form, notice that it definitely crosses the y-axis at negative 4. And so the y-intercept is negative 4. Furthermore, we can see that to hit the next point, we simply need to go down 1 over 1, which would give us a slope of negative 1. And so both ways of looking at it, looking at this graph, end up with the same equation, and but done in 2 different ways. So let's go on to the next 2 examples here. And so here we'll calculate a slope from the left to the right. We go down 2, which is negative, and then over 4. And so we end up with m is equal to negative 2 right 4, which is a slope of negative 1/2. We're now going to use the slope and one of the points. I'll just use the point on the left. Y minus the first y value, which is 4, is equal to the slope of negative 1/2 times x minus the first x value, which is negative 6. Simplifying, we get y minus 4 is equal to negative 1/2 x plus 6. Now we're going to distribute. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 6 is negative 3. 6 over 2 is 3. And we have equal y minus 4. Add 4 on both sides, and that leaves us with y is equal to negative 1/2 x plus 1. That is our destination slope-intercept form. Above that we have the intermediate step point-slope form, and still higher we have the slope calculation, and we're done. Let's go on to the next example. First, calculate the slope. Well, interesting. So in this case, we're not shown that the points lie on the grid. So let's actually calculate the slope here, given the 2 points that we have. So I'll label them from left to right: x1, y1, x2, y2. And y2 is 4 minus y1 is 1 over x2 is 8 minus x1 is 4, and we end up with 3 over 4 as our slope. Now we're going to take the slope, and one of the points, we'll use the leftmost point, y minus, the first y value is 1, is equal to 3/4 times x minus the first x value, which is 4, and so that is our point slope form. Following this, we're going to distribute 3/4 x. 3/4 times -4 is -3, is equal to y minus 1. Add 1 on both sides, and we end up with y is equal to 3/4 x minus 2. Again, we have our slope-intercept form, our point slope form, and our slope above that. So that's going to do it for this video and for this series of homework problems.